Hello everyone. In this video, I will be going to discuss previous year questions from JEE Mains 2023, and these questions are from 8th and 10th April session questions, and I will discuss one by one each question, and I'll provide detailed explanation for each question. So yeah, now let's start doing one by one. So yeah, here they are asking the major product P formed in the given reaction. So they have given this compound, and in the presence of alkaline KMnO4, heat and hydrolysis they have given. So yeah, here is it is simple concept. This is alkaline KMnO4. This acts as like it is an oxidizing agent, right? And it will convert these groups into COOH groups. But one condition is that the benzylic carbon should contain at least one alpha hydrogen. This is our condition here. In order to convert that group into COOH, that benzylic carbon should contain at least one alpha hydrogen. So if you see here, let me zoom it somewhat. So yeah, now you can able to see clearly, right? So if you see here, this is benzylic carbon, this is also here benzylic carbon, and this, if you observe here, it has two alpha hydrogens, right? The requirement is satisfied. So yeah, and here it is also, sorry, this is benzylic carbon. So this is also have contains the alpha hydrogen, and this benzylic carbon also contains one alpha hydrogen, right? So yeah, these three groups converts to COOH here. This whole group converts to COOH. So yeah, these three groups converts to COOH. So you can check the options over here. So they have given this should convert to acid group, right? COOH. It's not an option. It's not the correct option. And here also, here it, this whole group converts to COH, but so yeah, this is also wrong option. And here you can see the fourth option is correct option, right? These three benzylic carbon are having alpha hydrogen, so this will oxidize these three old groups into COH. I hope this is clear for you, right? This is These are all questions from JEE Mains 2023 and 8th and 10th April shift. So yeah, let's discuss this question now. The product P formed from the so yeah, now let's see this question. The product P formed from the following multi-step reaction. So yeah, they have given few reagents. Initially they have given this compound. So now let's start doing this. So they have given this one, right? NO2 over here and CH3. Now just see, they have given this Br2, where it will substitute, like you can check here. See, this NO2 is here. NO2 is electron withdrawing group, strong electron withdrawing group, and the CH3 electron donating group, right? As we know that electron withdrawing groups are what? Electron withdrawing groups are meta directing groups. I hope you know these simple concepts, right? And electron donating groups are ortho para directing groups. So yeah, if you see here, with respect to this NO2, these two positions are meta position, so it will attack on this. And if you see, with respect to the CH3, these are ortho position. Like, we'll get this NO2 CH3, here it is Br. So yeah, simple. Next they have given this H2PD. As we know that this is a reducing agent, right? Here they have given H2PD. This is a reducing agent. This will reduce this NO2 to NH2. Then we'll get this. It will reduce this NO2 to NH2, right? NH2. Here this Br and CH3. Now the next reagent they have given, that is NaNO2 HCl 0 degrees Celsius, right? So it will form diazonium fluoride over here. NH2 converts to N2 plus and Cl minus. So we'll get here this. This NH2 converts to this N2 plus Cl minus diazonium fluoride, right? And these two are Br and CH3. Just let me rub this. So yeah, next reagent they have given simply this H3PO4, right? Here we have this as acidic proton. Simply just replace this N2 plus Cl minus with H plus. That's it. So we'll get this Br CH3 H. So I hope it's clear, right? If you can check the options with respect to ortho position, Br is there, right? So option 4 is the correct option. So I hope this is clear for you. So let's move to the next question. So in this question they are asking order of acidity of the following hydroxyl compound. So yeah, whenever they have asked about acidity, just try to revise these two topics like acidity is proportional to the stability of its conjugate base. Of its conjugate base. Whenever if they ask acidity, the order of acidity just write its conjugate base and just see the stability of its conjugate base, and it is proportional to electron withdrawing groups. If any electron withdrawing groups are there, then acidity of that compound will be increases. If it contain electron donating group, that decrease the acidity. Now let's see these one by one. Here I'm just writing the its conjugate base, right? This is its conjugate base. So yeah, you can see here the thing is that here we have so here this oxygen have negative charge. It should be stabilized, right, with the groups. So here this CH3 due to plus I effect, it is giving the electrons towards, it is giving electrons again, so it is destabilizing this negative charge, so it is comparatively less acidic. Let's compare next option, that is B. So here we have, this is primary alcohol, right? And this one is tertiary alcohol. So yeah, let's see C, CH3, CH3, CH3. I am writing here the its conjugate base. So yeah, now you can see here, it is also showing inductive effect through this. It is giving electrons to this gain, right? So it is also destabilizing this conjugate base. So yeah, this is also maybe it will come last. So now let's see one more, that is they have given phenol. So if you write its conjugate base form, this is phenoxide ion, right? So yeah, here this negative charge is stabilizing due to resonance, so this will participate in resonance. So yeah, in this way this is stabilizing. So yeah, this can have more acidic strength. And if you compare one more, here if you compare these two, let me draw two more options. Here they have given OMe, and one more is that here they have given, I have told you, right, electron withdrawing groups increases the acidity. So here we have electron withdrawing group. This is electron withdrawing group, and here it is electron donating group, right? So due to this, here this electron withdrawing group withdraws the electron from this, and effective, we can say that effective resonance or effective delocalization occurs here. So this one have more acidic character, right? So E have a more acidic character, so you can eliminate these two options. So we have these two options, right? Correct options. We have eliminated these two, and then next, here it is. Here there is a possibility of participating in this group also will participate resonance with this ring, right? So the effective here the resonance is not that much effective with this oxygen also. So that's why, as compared to this one, if you compare these two, this phenoxyethanol have more acidic. Like phenol is more acidic than this one. So we will get E then C. E then C we will get, and then D. If you compare these two, this has more. This is more acidic as compared to this, because here this is tertiary alcohol, right? It is destabilizing this conjugate base. So yeah, option one is correct answer. So I hope you got this concept right. Whenever if they ask acidity, just try to apply these two concepts. Yeah. Now let's see one more question. This one. This is also simple question, right? So in the following, sorry, in the reaction given below, they have given this, and they have given this LiLH4. As we know that this is reducing agent. This is reducing agent, right? So yeah, as we know that this LiLH4 reduces this amide in C double bond ONH2 to, this will reduce this amide to CH2 NH2, and it will reduce ketone also. This ketone to alcohol OH CH. So it will reduce this ketone to alcohol and this amide group to amine, and it won't reduce this alkanes. So yeah, now you can see this. You can check the option here. This reduces CH2 and H2. Yeah. So yeah, this is, if you check these options, this is our correct option, right? If you can check it over here, this C double bond NH2 converts to CH2 NH2, and here we have this. It won't reduce this alkene, and yeah, it will reduce this ketone to secondary alcohol, and yeah, this is our correct option. So yeah, here you can see this table, that is reduction table over here. This is reduction table. This will be helpful for you in order to solve this type of questions we have solved over here, right? LiLH4. So you can see this LiLH4 can reduce this aldehyde to alcohol, and yeah, this ketone to alcohol, I just represented, like it will converts to alcohol, and carboxylic acids also it will converts to alcohol. It won't convert this alkene to anything, like it won't reduce this alkenes. So you can check these two, these three also. NaBH4 also, this is mild reducing agent, right? It won't reduce this carboxylic acids and esters. This is one of the important point over here, and it won't reduce alkenes also. And when it comes to this B2H6, it will reduce these aldehydes, ketones, carboxylic acid esters, but it won't reduce this acyl halides. So based on this table, you may get few questions. So yeah, this will be helpful for you. So you can take screenshot for this. Now let's discuss one more question. So this question is from polymers, right? So they have asked Buna can be represented as. First, you should know what are the monomers for this particular Buna. The monomers for this particular Buna are styrene plus butadiene. So yeah, styrene can be written like this: CH2 double bond CH This is the structure of styrene, and butadiene is this. So yeah, you can write it over here. This structure. Just wait. So this is butadiene, right? So you can write over the structure, like here we'll get CH2 CH. Just add these two. Like it might, like it will. this will attack on this and this bond shift towards, and we'll get one double bond over here. So you can write it like that. You can check options easily, right? CH2, CH, double bond CH, CH2. So yeah, just check the options. Here CH2, CH, PH6. So we should have this bond over here. So the second option is correct option. So you can check this. Right, this is a simple question from polymers. You can easily solve this question, and let's move to the next question. So here they are asking isomeric amines with molecular formula. So yeah, they have given this molecular formula gives the following test. Isomer E can be prepared by Gabriel Talman. So yeah, they have given molecular formula over here, and they have given options also. You just need to check each and every option. So first P. Let's talk about P. They have given like can be prepared by Gabriel Talamide synthesis. When it comes to Gabriel Talamide synthesis, this synthesis will be used for only preparing for let me write the whole sentence. This Gabriel Talamide Talamide synthesis used for preparation of only preparation of aliphatic primary amines. We can't prepare aromatic primary amines and also tertiary amines also. We will use this Gabriel Talamide synthesis for preparing aliphatic primary amines only. So you can check that option. So here P. So yeah, this is aromatic. We can't prepare aromatic amines from Gabriel Talamide synthesis. So yeah, we can remove this option, right? So yeah, so we can't prepare the aromatic amines from this process, right? Gabriel Talamide synthesis. So we can neglect this option, and this is secondary amine. So we can't prepare these secondary amines also through this process. So we have these two options only. Let's check one more Q. Then we so now let's check the isomer Q. So they have given reacts with Hinsberg reagent to give solid insoluble in NaOH. So this Hinsberg reagent we will use for differentiating the amines. So the Hinsberg reagent is, let me write it here. Hinsberg reagent. This is the structure of this is benzoyl sulfonyl chloride. S double bond O double bond O Cl. This is the Hinsberg reagent, and we'll use this for differentiating primary, secondary, tertiary amines. So yeah, if you treat this Hinsberg reagent with primary amine, that will be soluble in NaOH. But when it comes to secondary amine will be insoluble in NaOH. So yeah, it should be secondary amine. So if you check these two options, this is also secondary amine, this is also secondary amine. But let's check R. Let me rub this one. So let's check this isomer R, then we'll get the correct option, right? So let's check this R. Reacts with HNO2 followed by beta naphthol in NaOH to give. They have given this. See, if you have this NH2, when you treat with HNO2, it will form benzene diazonium chloride, right? It will form this benzene diazonium chloride, and then they have given followed by beta naphthol. The structure of beta naphthol is this. This is beta naphthalene. So here it will attack and we'll get one product. So here you can check these two options. Here on with respect to this ortho position, we have this. If you have anything on this ortho position, it will be like steric hindrance, right? We'll get steric hindrance over here if you check with this option. So it should be like over here only, then we'll get this thing. Like, let me write over here. So yeah, here if we take this, so we'll get structure like this: OH and double bond N. Here it is, and here if it is on the ortho position, we'll get steric hindrance, right? So yeah, first option is the correct option. I hope this is clear for you, right? So these are the questions I have discussed till now. So we'll meet in my next part of the video. In that video, I'll discuss few more questions. So yeah, I hope you have liked this session. So till then, keep practicing organic chemistry. So yeah, bye bye.